Great, thank you. Thank you guys for coming. And we're about to start. If you can grab a seat. There are not a lot of seats left, though. Cool. Welcome to the AGI Builders Meetup. And we are hosting with Tecton today. And if you guys can give a quick clap for Tecton for sponsoring the beer and wine, that would be great. And we also have great lineups. We have 3 tech talks, and also we have 3 awesome community demos as well. A little bit about the host. We already thanked Tecton, and also I'm from BentoML, and BentoML is a compute orchestration platform for Gen AI applications. If you're looking for deploy models or deploy Gen AI applications, check us out. And if you plan to post on socials, we are really appreciate it if you can use the hashtag, the AGI Builders Meetup, and you'll help us help more people to find us as well. Cool. For the first talk, we will welcome Alex from Nexa AI, and he will talk about frontier tech and use cases of on-device Gen AI.
Hi, everyone. So firstly, thanks for Eric for hosting this event, and thank you all for attending today's event. I'm very excited here to share you about our insights about generative AI and some of our work about generative AI. So I'm Alex. I'm currently co-founder and CEO of Nexa AI. Our company focuses on the pre-training, post-training of small language model. And we especially, will tailor these models for on-device use case. So firstly, I want to give some context for on-device AI. We already know that, large language model on cloud can really be helpful in different use cases. But we are actually doing it, in a pretty different way, which is to use the model that can be deployed locally, like on your laptop or on your mobile phone. And we've seen that the on-device AI is growing demand in different industry as well. So why do we care on-device AI? Firstly, we found that using on-device AI, especially for some multimodal use case, the latency could be optimized more. And on-device AI can protect your privacy. Also, if you only use your laptop to run the model locally, it is basically free, and it doesn't rely on your Wi-Fi connection. Even if the internet is offline, you can still use the on-device AI model. And currently, our company's work is mainly to solve the following challenges about on-device AI. Firstly, we've seen that language model currently is pretty big, and at the same time, the computation capability of your local device is pretty limited. So we want to optimize these language model so that they can be be faster and energy efficient when it is used locally. And also, we found the software infra for the on-device AI model is actually not as good as that for the cloud model. So we also did the SDK work to make the deployment of language model on the edge device faster. And also, we kind of develop our models, using some more innovative architecture or some customized algorithm to make it perform really good in certain capability. So a little more about Nexa AI. So basically what we do is firstly we've created an on-device AI model hub. Like we have a comprehensive summary of all of the language models or multimodal models that is suitable for local deployment. And we created our SDK. Basically, it's written using very low-level code. And now, like people can use our SDK to easily download the on-device AI model locally and create some interesting application right inside your laptop. And we also, develop our own small language models for local deployment. Our work has also, received pretty good attention from the community as well. For example, the model Octopus V2 is developed by our company, and it was ever featured as the second place Hugging Face among over 500,000 open source models in the April. And our work is also featured by Google I/O event and now presented inside their website as well. We are partnered with different hardware companies, especially deploy these models on these hardwares, and also we optimize our model, according to the chips on different local device, like Qualcomm's Snapdragon, this etc. And a little more about our on-device AI model hub. If you are interested in using these language model locally, without internet connection, you can explore our on-device AI model hub, and basically we can now achieve one line command to make the model run smoothly on your laptop in different operating system. And we also, different from other model hub, we pay attention to the metrics specific for the local deployment, like the RAM file size, parameters, etc. Also, we intend to build an on-device AI community. So if you are interested in small language model and local model deployment, you can have a try of our SDK. So next, I would like to introduce some of the models that we created. So all of the models I introduced here has associated papers relevant to it. And when we consider the models deployed locally, we actually need to be concerned of additional concerns such as the memory and energy consumption, as well as the latency. So this is because that we only have a limited computation, and since the energy and the hardware of your laptop or mobile phone is limited, so that's why we actually incorporated some new algorithm or some new architecture to make the model run faster. And the model Octopus V2 is developed for better function calling using local small language model, and we incorporated some new algorithm like functional token. We know that the traditional language models, for each token it represents some real human natural language, and using these models you need to use basically human natural language to describe a function and then execute it. And using this way, basically you need to, the typical function calling process will be that you take in user's query and then put all the available functions inside your context. And that means your language model needs to understand a long context and then output the result. However, if you use a local language models, it's been very energy the energy consumption is big, and you want to reduce the context as much as possible. That's why we propose this functional token. And the use of this functional token is that we kind of compress some specific function into a special token and incorporate that in the vocabulary of your language model. And now your language model can just output one token to represent one function. And that's the main secret sauce, we can achieve really fast and really accurate function calling using even a 2 billion parameters model. Here I want to play a demo of our model. So basically we use it on a laptop. And this is a demo app we've created. So what it can do is like it's a voice in, action out model, and we use a Whisper encoder to convert the audio information into audio token, and then our model can understand it and output one functional token to output the action. As you can see, our function calling, even using a local model, is really fast. It can be executed within 1 second. And basically, you can speak very natural human language, and then it can be converted into a function call. And the function call will be the functional token I just mentioned. And our model can extract the appropriate parameters as well. Let's take a look at this example, send an email.
Send an email to dev@nexa4ai.com and ask for collaboration.
You can say like send an email to a certain mailbox and ask for collaboration. What it can do is to choose one specific token that maps to send an email function. And then it can extract the correct parameters. Then it basically did a correct function call. And the whole process only consists of a correct token selection. That's why it can be very fast. And also other capabilities like set an alarm. Like basically, our model can convert any function into a functional token, and then your model after that, our model can output that token to represent that function. We also create some multimodal model. For example, our Octopus v3. This is a model with less than 1 billion parameters model. And what it can do is like it can understand both text and image. So it's an architecture with similar to Lava, which is like we also use a vision transformer to encode the image information into image token and mix it with the text token into our model. And the special part is that it only outputs a functional token. That means even using a multimodal model, less than 1 billion parameters, we can output a function call very accurate. Let me demonstrate our model using the demo here. So what it can do is like it takes in one text and one image, and then it outputs the action. So we tested this model on both iOS and Android. Let's say you want to purchase a pineapple, and you can just take an image of pineapple, and then you can say some very natural language like order 2 for me. Then our model can trigger the correct app inside your your mobile phone, and then do the fulfill your request. For example, you are traveling, you want to search the current scene in front of you. You can take an image and then say like, tell me history of this image. It will know like you want to search the background of the current scene, and our model can trigger the correct function call, and it can be mapped to another app inside your mobile phone. All of these implementation is locally, like the model runs locally. This is the Amazon purchase example. So this is another example, like to demonstrate the use case. We've seen like a poster with text inside it. The arrow of on-device AI agent is coming. And then we can say like send an email to a certain mailbox and explaining this poster. The model can understand and extract the text inside this poster and send an email. So this will be some use case for the model I just introduced. Now, what we can already achieve like using a 1 billion parameters model that can understand both like text, audio, and image, and then it can output the function call using the functional token I just mentioned. We have several papers associated with the model I introduced here. Also recently we published several other papers about the local LLM. We know like if you use the language model locally, the energy consumption is actually a very big problem. And if you have a really long context, that energy consumption is even more serious. So what we do is like similar to other multimodal model, we can treat the long context as basically like a new modality. Basically, the long context can be encoded into some embedding, and then we can use some projector to convert that embedding to be compatible with the conventional like a textual token. And then using this architecture, we can basically compress your long context and achieve 10 times more energy efficient without losing the accuracy. We also created some SDK, like currently if you use the SDK from Nexa AI, you can basically run these models, not just on the laptop, but also on the mobile phone. So we also did some benchmark with other frameworks such as MLC and Llama CPP. Many people ask about like the boundary of local LLM on mobile phone. Here we use a 5.3 model, which is around like a 4 billion parameters model. And then we choose a very old phone, 3 years ago, Google Pixel 6, now only worth 200 USD. And we can see that after optimizing the model, we can observe a really fast inference speed right inside your mobile phone. We see that if you use the latest iPhone and use our SDK, you can now achieve like around 20 to 30 tokens every second locally. Yeah, so this will be some kind of speed of local LLM inference speed on your mobile phone. Yeah, so for the last slides, I want to show some like way to contact us. Like we've already launched our local AI model hub, and you can contact us. Actually, we just finished our first round. Our latest fundraising round with over 10 million, and with many like branded VCs participation. So we are open to research scientists, deep learning engineers, and product manager and marketing. So if we are interested in our company, please contact us. Thank you.
Thank you, Alex. We're open for questions. If you guys have any questions.
Please.
Hey, Alex. My question is, I think it's a little bit cheeky to tell that your 1 billion parameter model is the same quality as GPT-4o, because you're checking like if 2 plus 2 will be 4, so you don't check like really intellectual tasks. And I think it's really interesting demo. I wonder, is it useful tool? Because for a while it looks like you need to provide anyway the whole bunch of information. And do you collect information about the user? Because I would expect that in that case it would be useful if it would know which John I want to send the email.
Thanks. That's a great question. So When I say like, we are kind of surpassing GPT-4, it's only in function calling. And if you look at our model's design, it is actually an action model. And more specifically, it's a small action model. Basically, like, for example, in your mobile phone, you may have 100, functions to be used. And then we can convert that into, 100 functional token I just mentioned. So our model is especially very good, in these 100, functions, this kind of function call. And actually, we open sourced, our model on Hugging Face before, and it's now been, extensively tested by many developers. As you can see, our model has ever been very trending on Hugging Face. It's actually featured as a top 2 place among all models. And if you are interested, you can download our model and have a test.
Thank you. What about, do you have use cases for which you use Nexa application?
You mean use case?
Yes.
Yeah, so actually, if you search our model like Octus V2 on LinkedIn, you can see, many developers, they are using our model to create, LLM operating system. You can basically, convert, create a application to convert, the human natural language, either voice or the text input into some action, like trigger some application. And now we are collaborating with, some big company here. Some of them are also our investor. And we will demonstrate more like a real use case in the tech event in the following months.
Thank you.
So did you mention that it also uses the NPU if available or not?
NPU?
NPU or any accelerator chip that may be available?
Yes.
It does?
We can now like make use of, CPU, GPU, and NPU.
You actually answered part of my question already. So it's all the large models like GPT, they go kind of all in on function calling as well. And you mentioned that your model is specialized in that 100 function calls are probably fine-tuned on device. Where do you see is the line that between when you should use a large model for function calling versus when you should use an on-device model for function calling?
I think, if you have a very well internet connection, and if your cloud model is cheap enough, you can use, the cloud model for function calling. But in some use cases, like inside the car, or you feel like the function call is pretty expensive, you can choose, on-device, AI model, especially when you have a pretty good laptop, like with, M chip, or like a pretty good Snapdragon GPU inside it. And in that case, like you can use the on-device, function call model. Also for some applications which requires frequent, usage of function call, such as, you want to achieve some automation in some daily app like Amazon or some meeting software, you may use it frequently. In that case, if you use, let's say, GPT-4o, it's actually not cheap. And if you use the on-device AI model, it's totally free.
Sounds like the factor is cost and internet speed latency, and
Yes.
not really quality. Quality is identical in your opinion.
Yeah, I'll say like internet and speed. And also like, the speed problem is is especially obvious when you want the multimodal input. Let's say you have a pretty large image. If you pass it to the server, it can take around 1 second. But if you just process it locally, the image transfer speed can be image transfer time can be saved.
Thank you.
Yeah, so Alex is gonna stick around, and if you guys can find him after the talks and talk to him if you guys have more questions. So for the next one, we are welcoming our co-host, the founder and CEO of Tecton, Mike, and he's gonna talk about building hyper-personalized LM applications with rich contextual data.
You forgot your bag here. Is this your bag? All right, give me a sec, everybody. I'm also on, great. I'm on like 15% battery, so maybe I have to go fast. All right, we good? Good to start? Okay, hi everybody, so I'm Mike. I'm one of the co-founders and I'm the CEO of a company called Tecton. Just quickly about like my past, who am I? I used to run some AI teams at Google that power the ads business, like all the real-time decisions that choose which ads you see. Helped start the AI team at Uber, built a platform called Michelangelo there, and that was some of the kind of like ideas behind us starting Tecton. This talk's not really about Tecton, it's about some new ways that people are building personalized applications, but I'll kind of mention it a little bit along the way. So one of the big types of value that's gonna be unlocked over the next couple of years and like changes in user experience is going to be in personalization. So what does that mean? That's all about like when you go and load a website, load an app, talk to a business, get customer support, whatever it is, it's gonna feel a lot more like they know you, that it's not just like you're getting the same experience as the next guy. And why is this important? Well, there's a study recently that came out that was from like one of the big consulting firms that was estimating what's the impact of AI, right? And we know like, hey, AI is gonna be huge and it's gonna do all these great things for everybody. But the impact of personalization by itself by 2030 is estimated to be $5 trillion with a T on global GDP. So, you know, there's very few talks that say a number that starts with T. So like what's going on with that? Where does trillion come from? Well, it's not just like incremental changes to, you know, it's not like slightly better ads on Google or something like that. There's some step function differences in and qualitative differences in user experiences that can be built. It's like we're gonna be able to do new things. It's not just like slightly better recommendations on Amazon. So today I wanna talk about one of the architectures that we're seeing a lot of our customers start to use as they try to figure this out. There's a lot, the industry's early, people are trying different things, but this is one of the things that we believe we will see more and more. And before I get into that, just quickly about Tecton. So at Tecton, we help people build better AI by making better use of their data. So how do we connect your business data to your AI? So your model will know more about your business, more about your customer, and that will be a theme throughout. We help companies like Coinbase and Block, we power their real-time AI, and that powers a lot of the experiences you see. Before I get started, who here is, can you just put your hand up if you're a student? Okay. Can you put your hand up if you're like an engineer, like a software engineer? Okay. And what about if you're a product manager? Okay. And what about data scientist or something like that? Okay, cool. All right, that helps me. That helps me. Okay, thank you. So for this talk, hopefully this works. Let's just have an example, right? The example is we want to crush Booking.com. We're going to start a startup. We want to build this really cool website. And the idea is, for our startup, when we go to the homepage, it's just gonna have the absolute best recommendation for you. It's gonna like know exactly the right thing. It's gonna show you one thing, it's the perfect thing. How do you do that, right? Booking.com doesn't do that today. And so we wanna use generative AI. One thing, like a naive thing we can do is just have ChatGPT behind the scenes, ask ChatGPT, hey, where should I go for my summer vacation, right? Just ask the question to ChatGPT. And we know what kind of answer ChatGPT is gonna give you. It's gonna give you a very generic answer. It's gonna say, hey, go to Greece this summer because Greece is cool in the summer. And that's kind of like a generic answer for everybody. It's almost like you're getting a lowest common denominator answer. And just calling back to the previous talk, like, let's figure out how we can beat ChatGPT, right? So what we're getting right now is kind of like we're talking to a stranger. They may be an expert, ChatGPT's smart, but it's like, doesn't really know you, right? So it's just gonna say Greece, go to Greece. But what we really want is, we want someone who's like our best friend, like knows us like our best friend. It's a very personal level of understanding, and they have high expertise. So they have high context and high expertise, and then they can say, hey, we know you really like rock climbing. We also know you like dry desert type areas, and there's something special happening in Utah this summer. You've never been there, you should check that out. That's a way better recommendation. So how do we get this kind of recommendation? Well, we can, should we fine tune the model? Well, that kind of like improves the model's intrinsic knowledge. Model's not gonna have like much information about you. Prompt engineer, that's kind of like, we should always do that, but it's kind of like asking the question a different way. And so the obvious kind of like thing we're gonna circle around is RAG. And what is RAG? Fundamentally, it's just enabling the model to go out and get more good information so it can make a better decision, right? And so let's just look at like what the naive version of RAG is. And this is like a thing that's not super commonly done, right? There's way better ways to do this, but let me just take this query. Where should I go for a summer break? Let me embed it. Let me then compare it to a bunch of other embeddings for different cities, and then I'll pull out some of those cities and pass them to an LLM, and then the LLM will make a decision, right? And it'll say, hey, visit Greece. So what's happening here behind the scenes, we're making a prompt that we're passing to the LLM, and we're injecting these candidates, these cities, into the prompt, right? It's just like a prompt template when you use LangChain or something. And the problem is, like, how is the model gonna make a decision based on Paris? It doesn't have a lot of, it's just like, what information does it know about Paris? Whatever was in its training data, right? And so, so this is kind of like what it looks like. We have this prompt with some candidates in it, and it goes through to our LLM. There's not a lot of context going into this model. And context is really the information that allows the model to make the right decision about this situation, for it to reason about this situation. So how can we provide more context? So instead of, like, what if, instead of having just like the city names, we had like a whole bunch of information about the place, right? Like, what's the weather? What activities do people do there? What's the budget you need? What kind of cuisine do they have? And we can just think of like a million different things. And this is, I showed, I don't know, 20 things. We can think of 200 things, right? And it's actually not unlike what you would do in predictive machine learning when you're building features, right? Features is a very common thing. We want to productionize those and put those in a recommender model. And so those can be part of the context here. And this data, like, why could the model not know this? Maybe it could know a lot of it, but this data might be updated. It might change. It might be new since the model was trained, right? And if we then inject this data into the prompt, then the model gets a lot more context to make its decision. And you have to do an extra little like data engineering step then, though. You have to kind of like grab the data about each of these locations, do some cool join stuff, enrich the context, and then you have a cool prompt with way better information within it. And when you do that, you get a slightly better recommendation. So the recommendation might say, hey, well, this summer, you should go to Paris because the Olympics are there. But this is still not really like a personalized response, right? Maybe I don't even like sports. Maybe I'm like, maybe I don't like French people, who knows? So I don't want to go to Paris because it's not related to me. So how do we get a personalized response? Well, we need to provide the model personalized context. Wouldn't it be great if the model knew about me or about the user, right? What kind of stuff could the model know? Could we tell the model? What are the user's preferences? Where have they been before? What is their budget? All of that kind of stuff. What do they like and don't like? So we want to pass this as, like, enrich the prompt with this type of context as well. So we pass this, we can inject this into the prompt. And so now the model's going to get a lot of information about each of the things it's considering, each of the candidates, the cities. It's also going to get a lot of information about you, about the user. And if we can pass it to the model, well, we have a new data engineering problem. Now we got to get all this user data and join it together. It's a whole other, now we're expanding the scope of the problem we're trying to solve because we need, if I'm a data scientist, well, now I got to get the data engineers involved. And for me to productionize this, I got to get the production engineers involved and stuff like that. That's a little bit more challenging. But then I can get like a much better recommendation. Go to Utah because blah, 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 it's perfect for you. So the moral of the story here is the better the context you can provide to the model, the better the quality of the response. And if you get that right, you can go from a kind of like generic answer to like a really hyper-specialized point-in-time recommendation. And this is like a super personalized recommendation that can be like, hey, very close to where you are right now, a spot in a class just opened up and you've always wanted to learn this thing, learn how to do this specific culinary thing. And that's the type of recommendation that could never exist before. So this is what I'm talking about of like a different kind of experience gets unlocked by really hyper-personalization. And this is just like a wacky example within travel, but every company has the experiences, their customer experiences that will get unlocked if the way the company shows up is a lot more personalized to the customer. If the way the customer or the company shows up is a lot more like human. So how do we do this though, right? What has to actually happen here? We got to find a way to ingest all this data, transform it, extract all the knowledge from these data sources. We have to store it, keep it ready for retrieval. We have to serve it in real time at the time when we're loading the page. And we have to join it all together at the right time, right? Maybe you join and retrieve in different order. So this is like a lot of data engineering stuff to do. And we want to do this. If you go to like a Google, if you go to a Facebook, there's literally teams that are hundreds of people that build all the infrastructure to support this. This is like a huge thing. But we don't, no one's company is going to pay for hundreds of people just to do this one, just to support this one use case. So how do we control the cost? How do we do this simply and quickly without having to hire a gigantic engineering team? How do you let one engineer do this? How do you let 2 engineers put this into production? Build it and run it in production. So and also like how do we build these amazing contexts without having a huge engineering team? So I want to talk about the couple of different layers of context that we can add in. The first layer is kind of a cheat. It's just no context. We already talked about that basically. And it's kind of what like naive RAG is. And this one sucks. Don't do it. It's going to lead to bad results. The second one is where we start looking at a certain class of data. The certain class of data is batch data. This is data that is like slow moving, data that we've known about before. It tends to have user preferences and history, past profile data. And if you've got a data warehouse at your company, this is like plugging into Snowflake or plugging into your data lake, right? We want to go get the person's history. Where did they go before? What did they say they like in the past? And we can have this notion of like a context platform, something that's responsible for collecting all the data and joining it all together and constructing and assembling that context. And as like a little bit of like a teaser kind of thing, like this is what we do at Tecton. This is what we're all about. And so this is really hard to do though. This is even just this first step. If you're just in like a solo developer, this is tough to do because now you're building a productionized data pipeline if you're trying to build this product. You have to do all this stuff interacting with data lakes and serving this data, joining it together in real time. Also, you have to figure this all out to evaluate these systems. You got to do it all historically. You got to recreate all of these requests and all of this context historically for you to figure out, hey, was this good or bad? It's a big problem. So one of the things that we do at Tecton is we give a very easy workflows for somebody to do this. I'm not going to go through this in detail because it's a bunch of code, but it's actually much simpler than you would do otherwise. It lets you write a very simple definition in Python that says, hey, this is the data that I need to extract and the type of transformation we should have. Think about it like a little function to describe a piece of knowledge. And then one line to create historical evaluation data sets, one line command to productionize it, and also one line to call and retrieve this data as context in production. So this is like trying to take the work of 10, 15 engineers and bring it all together into as easy of a package as possible for a single engineer to go as fast as possible, right? And then when we have this batch context, we can make recommendations that are based on your history. Hey, because you like traveling to places with lots of history, we suggest going to Japan, for example, right? So that gets us to level 1. Now let's talk about what level 2 is. Level 2 is when we can unlock and get a signal, a little bit more of a signal of what the intent the user has right now is. And intent is super important in personalization. So think of like, what's the person into right now, right? Well, wouldn't it be great if we can connect to the data that tells us like what pages they were just looking at, what were they just searching for? Oh, they were just watching kayaking videos. Maybe they're really into like sports or whatever activities. Let's make some recommendations alongside that. Well, this kind of stuff is built on streaming data. So now we're going to connect to a Kafka stream. And now we got to do some streaming data pipeline stuff. And I bet you a lot of the people who are like really into LLMs and AI and stuff here, you're not like streaming data processing experts. And so what we find in companies, in real world companies, it's just like 2 different types of people. Now you got to bring in a lot of different personas, and it's like the scope of the project grows more and more. But if we can do this integration with this kind of data, then our context is that much better. It's got batch data and streaming data. And that's a much higher quality context, and you get a much better recommendation. But building this stuff is way harder, right? You have to build and monitor and operationalize streaming data pipelines. And another thing is if you've never used this stuff can get expensive. We've had customers who did the wrong thing before we were there, and they blew 100 grand in a month. Another customer blew 100 grand in one day accidentally because they had really high volume of data and they set up the pipeline the wrong way. And so it's also high risk doing this stuff if you don't know what you're doing. And by the way, it's a shame. Like we should have solved this problem long ago. It kind of sucks that that's the state of like modern software engineering, but that's how it is. So so if you want to build a piece of streaming context in Tecton, same thing. Write a small snippet of Python code. Everything else is the exact same. We treat streaming data, streaming context the exact same as batch data and batch context. So it's the exact same. And then you can have these great recommendations that are related to stuff like, hey, we were just recently looking at Japan, so we're going to give you some Japanese recommendations, right? So that gives us a way better type of context, way better quality results. The third kind of layer here, level 3 for context, is real-time context. So this is like where you really get some good stuff. So this is where we're starting to take into account the user's current context, where they are right now. Like literally, where is the phone that's loading this web page? Or what is the information they just provided to us? It can also be context-based, real-world context, like what is the weather where you're at right now? Or what is the traffic? And these kinds of signals are huge for allowing you to provide non-generic recommendations and more human-like recommendations. When I was at Uber, the ETA, when you're like calling an Uber and it says, hey, your car's gonna be there in 5 minutes, we were building the ETA systems that were generating those scores. And the day we added in real-world traffic signals, the ETAs got like way more accurate. And that's because we had this real-time context. Like we got the signal of like what's happening on the ground in the real world, and that allowed the model to be that much better. So what is real-world context? Well, it's both like APIs, like, hey, let's call out to the weather service or whatever to find out what the weather is. But it's also stuff like what information did the user put into the app right now, like a query, or what is their location? And so synthesizing all of that, running all those data pipelines and turning it into, we want to do all of that, extract all that information and turn it into one piece of context that's really compelling. Even a harder data engineering problem. Building real-time data pipelines, productionizing this stuff is really tough. Try getting it running fast enough. Try getting it running in production at the speed and reliability that you want to power your actual company's core product. You need more people. It's just like a lot of work. And connecting to third-party data sources, and then figuring out how to balance speed and cost. So I'm not going into all the problems here, but like it's just like a really challenging, gigantic explosion in scope. So quick example, hey, I want to have a feature that's or a signal that is describes how far is the user right now from this destination. Like that's a really good example. Maybe the user is on foot and they don't want to go somewhere really far, right? So you want to have that as an input. This is the code. It's just you literally just write that Python code and all those other one-line things are the exact same. So this is kind of like, the idea is how do we speed up developers with the Tecton platform. So with being able to use the query, user location, local events, etc., you can have a way more personalized recommendation, similar to the one I was saying before of like, hey, there's a spot that just opened up in a class right near you right now. And that's where you start to kind of like get these qualitatively better experiences. Okay, so I actually have so that's kind of like all of the layers of personalization, but I have a bonus level, which is something that is really interesting because we're starting to do this with our customers, and I think it's gonna be like a really big thing. And this is the idea of integrating memory and integrating feedback. So what if you can allow the customer to then go, yeah, no, I don't want that. Like I actually I want to be somewhere warmer this summer. Well, this is kind of the similar kind of thing to integrating conversation history into your LLM application. It's just another piece of context that helps the model reason about what you should recommend to your user. And so this is something that's coming soon in Tecton. It's like a really crisp way to integrate all of this stuff together for a single developer to be able to build these applications on their company's data. Okay, so I'm gonna finish up. What did we learn? Complex personalization is important, but it requires context personalization, right? Great context is very hard, and there's just gonna be this new, context platform. There's gonna be something, and this is what we're working on and what we've been building for a long time at Tecton. There's gonna be a new piece of the stack that is all about managing this stuff for people and helping companies, helping teams, helping developers get that architecture up and running really quickly. This matters across all types of use cases. It's not just it's travel recommendations, e-commerce, communication, content, whatever your world is. Better context equals better recommendations, better personalization, and better decisions from your LLMs. This is what the architecture looks like. I think you're gonna see, it's super early in this space, so if anyone comes up here and tells you this is the exact way to do it and it's gonna be like this forever, that's not the case. This is the best guess of what it looks like right now, and this is what we're helping companies with. But 6 months from now, when we're all back together, it's probably gonna look somehow a little bit different. But we're feeling really confident about this because we're seeing great results. But if you're in a company, there's more stuff to do. How do you version all of this stuff? Like practically in the enterprise, how do you work together with other people? We said you need all these other people involved. How do you control how the data is being used? How do you debug it when it breaks? How do you ensure it continues to stay accurate and detect when it breaks? That's all the kind of stuff that we solve at Tecton. We help you build AI that really knows your users. And you can try it out right now at tecton.ai/explore. We're around, and thanks everyone for coming by. It's really cool to see everybody. I'm happy to also take any questions. Thank you.
Thank you, Mike. Any questions for Mike?
Thank you for the talk. I used to work at the personalization team at Indeed, and
Indeed?
yeah,
Nice.
I just wonder what could be the data structure that optimal for context, because in the past, we mostly deal with structured data. Right now, with LLM and a bunch of new paradigm, there need to be a mix between structured and unstructured data, and there are new suggestions on using graph data as well.
Yeah.
So, do you have any take on what is the best way to represent the context?
Good question. This is a step that I didn't show. So the question is you have all this data. How do you actually when I showed the prompt and then I just kind of skipped over, I was like, yeah, and you just inject the data into the prompt, right? Well, there's a lot of technique in how you inject the data into the prompt. And that's still very much an open question. So we've got some techniques that we've kind of figured out, but I will not tell you that we've totally answered that. What we have is a step where we have a model that will take in that context data and actually distill it, summarize it to be injected into the prompt. So it can create it as, it can summarize it and be as much information preserving as possible while shortening it as much, so we're not like using so many tokens. Does that make sense?
Okay, so that was like for cost effective to summarize the unstructured data and that combined with
Unstructured and structured, yeah.
both unstructured and structured data. How do you know that the summarization is condensed enough? Like, is there any other LLM to evaluate that? So that's still a very...
It's just experimental right now.
Right.
It's hard to know. You worked at Indeed. Do you know Donald McMahon?
Don't know.
No? Okay. I used to work with him. Okay. Yeah. Oh. Yeah.
So are you thinking about using ontologies and knowledge graphs
Well,
to represent the data?
good question. Yeah, that's built into Tecton. So the question is, are you gonna use knowledge graphs basically and ontologies? So Tecton kind of gives you well, you're seeing right here, like this is a graph of all of the data flow from your raw data source. Like basically this is think of this as your warehouse, your Kafka stream, whatever it is. And over there on that side is your model. And there's a whole DAG of processing this data all the way to get there in real time. We know in Tecton, when you use Tecton, we know what each data source, you provide a bunch of metadata or we infer a bunch of metadata. So we know what all this data represents. It's important to have a semantic understanding of that. And that allows us, similar to what we were just talking about having the model kind of like encode the context properly. It allows us to encode it properly because we know what the data represents. And so then we can say, just do smart things like when you put it into a sentence together, you can put concepts that are similar to one another beside each other, for example. Yeah.
So do you feel that like LLMs can traverse the knowledge graph in a really efficient way?
I don't know if the LLMs themselves are traversing the knowledge graph, but we are, what we are doing is kind of like projecting it to a flat piece of context that we can put into the model. Yeah, good question.
So in your example, it kind of seems like you're building kind of like an AdSense plugged into large language models, and basically the more information you extract from a user, the better answer you get. So I guess, are you interfacing with AdSense or any sort of data collection things right now? And
good question.
Plans?
No, we don't have primary data sources. So what we do is basically every company has a lot of first-party data, right? If you work at Indeed, for example, you have a bunch of jobs data, right? And that data that every company has is actually that company's like proprietary secrets, their competitive advantage. Monster.com doesn't have Indeed's data unless like Indeed owns Monster.com, which I don't know. But that's the idea is like companies unlock the value of like the value of AI and their ability to differentiate and competitively differentiate is when they can use their proprietary data better. But it very much is important to be able to connect to like other APIs and stuff like that that are just like generally available data, like like I was saying, traffic and weather and stuff like that. We're building those integrations over time, but that's not the primary thing for us because we find companies get the most value if you let them plug into their primary data first. They can figure out how to plug into like third-party data and stuff like that for now. Thanks, good question.
Cool. Thank you, Mike.
Cool. Thanks, everybody. I'll be
And,
around. We can answer any questions.
Yeah,
Thank you.
if you have any questions, I think there are a few Tecton team members here, and you can find Mike, Adriana, and some who is with Tecton. Raise hand. Yeah,
Joey.
there are a couple of people there.
Joey
If
and
you have
Bobby.
any questions, find them later. Cool. For the next talk, I will do a quick survey. Who heard about Compound AI system before? Raise your hand. Compound AI system. Cool. People who didn't raise, then you will probably learn a lot from the next talk. The next we'll welcome founder and CEO of BentoML, Chaoyu. He's gonna talk about the rise of a Compound AI system.
All right. Cool. Thank you again, everyone, for coming here. Excited to have the third talk coming from a startup CEO. My name is Chaoyu. I'm the founder of BentoML. We build a developer platform, help AI teams to build and scale compound AI systems. That's the topic of today. If you haven't heard about term, I assure you this is something that's highly relevant for any startups or enterprise AI teams who's looking to build a competitive edge in their AI offering. To get started, I think when generative AI, ChatGPT first came out, a question a lot of us were asking is, will a single AI model to rule them all? Right? These are large foundation models that can handle a large variety of tasks, and all you have to do is simply changing the prompt. They can be used with additional context. You can have chain of thoughts to do more complex reasoning. And as a builder, it's kind of depressing to think, right? Those large models can do so many things. What's left for us to build? But over the past year or so, I think it's becoming more and more obvious that specialized system that's leveraging actually single model becoming having a tons of limitations when you're actually applying them to a lot of specialized use cases. Here are three primary areas that you will find limiting with a single model approach. The first is hallucination. When the model is not given enough context about the problem, doesn't know what, or a certain knowledge, it could produce random stuff that's not factual. It also have very limited knowledge, word knowledge, or don't have access to internal proprietary data set, which is something that Mike just talked about a lot, that help you build more personalized AI applications. And lastly is domain specification. This type of large model are typically trained for general purpose. They may not understand the specific type of data that you have, a type of modality, or being able to integrate with your specific systems and APIs. In fact, if you look at some of the most advanced AI systems companies have shipped today, they all shifted away from a single model approach. Instead, they are often built with multiple interacting components and models. We all know ChatGPT is powered by GPT-4 series of models, but they also have components like code execution, web browsing. When you ask it to generate the image, it knows to talk to another model that OpenAI has called DALL-E to generate image for you. Similarly, in GitHub Copilot, it contains tons of fine-tuned models and being able to search through your code base, through embedding models, and being able to deeply integrate it with your code base. And Apple Intelligence is another very interesting example. I think Apple is really did a great job kind of building an AI offering that only they can do. If you've been following what they are doing with the latest iOS release, they're integrating AI capabilities deeply into all the apps like emails, notes, or even a keyboard. They can utilize their own device context for the model, and they implemented a tons of privacy-first safeguard features around how people accessing those models. And it's not just one LLM. They have tons of specialized models for proofreading, for helping you take better pictures, and things like search through your photos. So what exactly is compound AI system? We essentially just define it as an approach, conceptual approach, that you're building an AI system with multiple interacting components instead of relying on single models. Some of the common patterns including composing multiple models, each solving a different task, or multiple calls to a large language model to orchestrate a workflow. And oftentimes include external API calls or fetching external data sources. Here are some of the more practical examples that we are seeing at BentoML, what people are building with this compound AI approach. First example here is video or media analytics. I think this typically comes with, for example, a live video feed that you want to chunk into individual frames, and then being able to analyze what's in the frame. Right? And depending on the type of use case, the latency requirement, you might be involving additional models like object detection and image classification, maybe in combination with a vision language model to do more complex analytics. Another interesting example I want to mention here is voice chat agent. This is a very interesting pattern where you allow large language model or AI LM agents to be able to speak to a user. This is very powerful for making phone calls, automating a lot of tasks that requires talking to a human or maybe talking to an AI one day. These are all very exciting use cases. For the rest of the talk, I want to talk about how we're seeing AI teams building this type of compound AI in action. What are some of the common patterns and challenges? The first most interesting part is using specialized models. I think typically when I say that, I'm referring to traditional machine learning models or fine-tuning of a large foundation model. And lastly, is pruning and knowledge distillation, which essentially leverage a much larger model that's a generalist who can do a lot of different things and turn it into something that's specialized in one task, but oftentimes a much smaller, cheaper, and faster model. And to give you a more concrete example, let's say in a large language model application where there's a processing step, you want to look at the input user query and decide if the user's query is harmful, is toxic. A typical approach you would do with a large language model like GPT-4o Mini is you write a prompt saying, determine if this sentence contains toxic content. Here are some examples, and return yes or no. Right? It's super easy to build, and if you look at the cost, it's roughly around $80 per a million sequence like this. And this is a very simple task. If you come from more traditional ML or NLP background, we've seen many models like this that can solve this task. In fact, if you fine-tune a BERT model to solve the exact same task, you'll be able to end up with a model that's perhaps 1,000 times smaller than GPT-4o, probably even more. And the cost ended up is over 1,000 times cheaper. This may not make sense if you're just getting started building a prototype, but as you scale things up, let's say you're paying 100,000 for GPT-4o for solving, for classifying a large number of texts like this, that essentially cut your costs down to less than $100. With specialized model available, another powerful pattern is composing these models to accomplish more complex tasks. So here, this example is for extracting information from a complex documentation. A very common use case among finance, among a lot of industries, where you have documentation that contains different segments, charts or tables, and being able to extract structured information from such document, being able to use those information to power an application or an automation process have extremely high value. And even though with a lot of advancements in visual language model, I don't think there's a model that can really nail this task. And oftentimes, different organizations have their own type of documents, maybe different DSL, different style of charts, that a general model may have never seen anything like that and fail to understand. A very common approach we have seen is that you use very specialized components that, for example, start with analyzing the layout of documents, where are the different components, and then, for example, use a special model to understand what are the content in the table, and then a different model that's trained with tons of different chart images, and being able to allow you to ask questions about a specific chart with additional data you might be able to parse from the document. And sometimes your document may also have handwritten characters, so OCR model can come in really handy. And with those structured information available, you can start building more additional layers, applications much, much easier. This pattern actually enables us to do some of the really critical components in large language model application safety and enhances trust. Here's a very simple example. Let's say you're building an LLM internal self-hosting endpoint for internal application that's highly sensitive. And you want to make sure that this any input to this large language model shouldn't be injected. Any user input that's harmful, we shouldn't forward to a large language model. And any PII information shouldn't be sent to the external large language model, for example. What you can do is you can orchestrate this in a way that have multiple models in your pipeline, before you pass in a user query to a large language model. And with the large language model output, you can again use a small language model to determine if it contains toxic information or fetch additional information from the web, from your internal data sources to do fact checking. This allows you to build more robust and more safe AI systems. Another powerful thing to compose multiple model is multi-LLM routing. This is a very popular topic. We see a lot of large language model applications are handling a variety of different tasks, but those tasks comes with very different kind of performance needs in terms of how complex they are, how much cost they are, what's their latency requirement. This approach essentially says when I receive a task, I take a look and do a heuristic evaluation. If it's a complex task, I may forward it to a larger, more expensive model. If it's a very simple model, a simple task, I may use a cheaper and smaller model. And oftentimes combined with specialized model or fine-tuned model. And in some of the experiments we saw, this can help you cut LLM costs up to 90%. By the way, we have an open source implementation of this built with BentoML on our GitHub repo. Feel free to check that out. And next, I want to talk about another very important pattern in compound AI, that's function calling. Show up a hand, who here have heard or used function calling before? Great, most of you have. Function calling, I think it's really critical in this type of AI system because it allows you to integrate AI application with external systems, with your existing system. You can ask the agent to help you update your CRM, change something in your database, which all sounds very dangerous to do, I know. That's why trust and safety is important. So there are essentially two important factors to consider when building function calling. The first is parameter extraction. I think most LLM providers perhaps have some variety of this built in. Typically, you can do enforcing the output to be a JSON or structured in a schema that you provide. More advanced scenarios could also enforce the LLM to output something that match a regular expression you provide or a certain type of grammar that's applicable to your application. Another component is function routing, which essentially means when you have multiple tools and functions available, how does your application decide which function to use? I think intent classification routing is actually surprisingly a very common approach. So you directly look at a user's query, do some heuristic, and decide which function to use. And you simply use large language model for extracting the parameter for this given function. And this is often used together with conditional routing, where developers use their code and to more explicitly assign a function for a large language model to call. And another popular approach, I think a lot of us, when we first heard about function calling, that's the first thing we learned, is large language model-based routing. This is essentially saying I will give all the description of different functions that's available as the input context to my large language model, and have the LLM figure out what are some of the functions to call, what are some of the parameters I need for each function calling. This approach oftentimes depends on the model's capability. Not all the models support all the different type of function call capabilities. Some of them can only support calling one function at a time. Some of them are more powerful and allow you to run multiple sequential functions or run multiple functions in parallel. With function calling, a big use case actually is empowering you to connect your AI system with your proprietary knowledge and data. I think RAG and embedding-based search is a very popular approach. There are also more advanced scenarios where you can generate a specific type of DSL or query to retrieve proprietary information from your internal data source. This could be also internal API calls to other systems that you have. And I think Mike mentioned something like this earlier. A lot of the proprietary data and knowledge are truly what helps you to build a unique a competitive advantage that only you can build. Lastly, I think caching is another mechanism that widely used in this type of AI systems because running some of the larger models can be so expensive. Typically, we have seen caching implemented in every component in a stack. Some of them you don't need to worry about, like prefix caching or internal caching that's built into most of the large language model inference runtime. But there are indeed quite a few parameters that you can tune those behavior to optimize them for your specific use case. And for scenarios where you want to do higher level caching, we typically see semantic caching, which essentially means when you have a user query coming in, I use additional system like embedding and find very similar queries that's been processed before and use those output to respond immediately. This can also largely reduce the number of repeated calls, repeated questions, and avoid the expensive large language model inference. Towards the next, last part of this talk, I want to talk a little bit about building and scaling compound AI system. That's what we do at BentoML. I think a lot of teams, as they started building this type of AI system, they often started out with accessing AI through an API, right? And we've seen a lot of framework that's focused on orchestrating the business logic of your AI system. There are RAG frameworks, there are agentic frameworks, and they all do very similar things. That's a Python framework helping you orchestrate your business logic. I've seen teams like that, teams who grow out of that and start rolling out their own thing. But as the real challenge comes after you start introducing more moving parts, right? Introducing your own specialized model, needing to run inference with those models. Some of those models need real-time API access. Some of them should be running as an asynchronous job. And some of those models you might not need them frequently, and you want to scale them down to 0. So in order to build this kind of system, we find teams being slowed down because they can't easily get all the compute and different components set up, even just for simple evaluation runs. Not to mention when you have such complex pipelines and systems running in production and how to optimize them for performance. And with this trend, we've been thinking about how we can empower AI application developers to more efficiently leverage this pattern, right? I think 3 areas that we've been focusing on. One is allow you to prototype much faster, right? With all those different models, they may have different GPU requirements, different architecture decisions. In fact, that's one of the most powerful things about compound AI, is that you can improve the system through tweaking the system design, tweaking the architecture design, instead of going through a very lengthy and expensive model training. The second is production-grade efficiency and scalability. Again, I think with the introduced complexity of multiple models and components, it becomes increasingly hard to optimize them in distributed environment with so many GPUs. And we want to offer the base infrastructure layer that allows developers to do so. And lastly, since such system needs access to your proprietary data and systems so often, we want to make sure such platform is secure for your team and runs in your security environment. At a very high level, our approach is that providing some of the key components, 3 key components: AI application logic, allow users to define, as well as the model inference, and lastly, cloud infrastructure, cloud architecture. All those key design decisions when building a system, allowing application developers to put them in one place in Python, right? And our system takes such definition that's built on top of our abstraction and allow you to scale them easily in your cloud or our cloud. With that, that's all of my talk. Thank you again for your time.
Thank you, Chaoyu. Any questions for Chaoyu? Great, awesome. Thank you. Thank you guys. And for the next sections, we're gonna do community demos. Instead of like tech talks, the community demos is like a quick fire 5 minutes demo. And the first one, let's welcome Jojo from CambioML. And he's gonna show us what he has built.
Cool. Hey, everyone. I'm Jojo. I'm the COO at CambioML. I'm excited to be here at the AGI Builders Workshop. And yeah, basically at CambioML, we're building a vision language model for extracting data more accurately from documents. So I'm going to just quickly go over the product that we're building, the technology that we're using to solve that product, and then have a quick demo on some of our solutions. So first, the product. Basically, the main use case is we have these customers who have lots of documents, and they need to parse these documents. And they have a whole team of people manually extracting the information. Then they have a whole other team of subject matter experts who need to rate the information, provide insights, and finally, they need to build dashboards or build reports to summarize that information. And at Cambio, we're looking to automate that process with AI. Basically, process all that information with a click and change all those human effort from thousands of hours to minutes. That might be a bit of an exaggeration, but so the technology that we're looking to build to empower that is any parser, which is built on top of our custom language model, Cambio LLM. Basically, it's a large vision language model. We've trained it on over 1 million financial documents. And what we're looking to do is combine the mutual benefits of an LLM and OCR. So like an LLM, we have the high accuracy. We're able to do things like remove private information or accurately extract data from charts and tables. But it's also lightweight like an OCR, and it can do inference very quickly. And just like quickly showing some of the benchmarking we're doing as we're developing this, we've compared basically any parser plus an advanced RAG system, which we're calling any retriever, comparing that with RAG-S benchmarks like context recall, precision, and comparing that to some standard industry RAG systems, and are getting good results. And I have a white paper link there below, but I'm going to speed through that. Yeah, so next, some demos. So first, we've built this sandbox where anyone can take a look. But basically, you can upload your documents and see how well it performs. So we have a couple sample ones. I'm going to pick this portfolio statement. And then this extract plain text is basically just going to extract the document in Markdown. And we can take a closer look at the document. Oh, got it here. I'm going to try that again. That's what I get for doing a live demo. But yeah, basically, it's just a dummy portfolio statement. There's some tables. There's some private information that we want to make sure we redact. More tables, and then like a little chart at the end. Okay, still running. Okay, awesome. So that, basically you can see we extracted it all into Markdown, got the data from the different tables, kind of glossed over it, but we've redacted the different private information. And then also, I want to see how it did on the chart. Yeah, pull all the different information from the chart as well. And then finally, I just want to show this leaderboard that we've also built. So basically, it's a way for people to easily compare any parser versus different like extraction technologies out there. Like, so yeah, first you can either pick like a sample sample document. I'm going to try this sustainability report. And then you can see you can pick different ones like Llama Parse, Unstructured, GPT-4o, or Cloud. And I'm going to work on adding more in there. But yeah, it's just a quick way to compare any parser versus these other technologies and see how they do. So yeah, there's the outputs, easy to see side by side how it extracted the information. I think I'm probably up on time, so we'll just leave with this slide. Thanks for listening. Would love if anyone can check out all of these links, give us some good feedback, especially let us know if you find any documents that any parser struggles with, because we always want to make it better. And yeah, come say hi after.
Thank you. So for the next one, let me ask you guys a question. Who have built agents before? Raise a hand. Who has built a multi-agents application before? Raise a hand. Great. For the next demo, we have Sally and Regina from Camel AI, and they're going to talk about their multi-agent orchestration framework.
Oh, nice. Yeah, hello guys. Nice to meet you all. I'm Sally from Camel AI. Actually, we have our whole, basically a whole team here except our CTO. So Camel guys, could you raise your hands here? Yeah. Like I will do a briefly intro of what Camel is. So AI-based agents, like regular agents, but they never need coffee breaks. That's why we build agents in a multi-agent system, right? Camel is, at its core, it's a multi-agent system. So here I will lead you guys to our main website. So Camel AI is the first LLM multi-agent framework. And it's also an open source community dedicated to finding scaling a lot of agents. So at its core is a multi-agent system for building, for task automation, also for world simulation, and also for data generation. Let's see. So we can also, you can also create powerful agents with our different components. We support up-to-date models, also various of tools. We do provide seamless integrations with different and popular platforms, such as like Ollama, GPT-4, Redis, Milvus. Here I will go back to my presentation. So I will show an example here. So this Turkish shooter, I guess most of you guys know who him is. It went viral on the in this 2024 Paris Olympic with his hand in his pocket while doing shooting, but won the gold medal. That's pretty cool. For those who don't know him, how can we get to know him a bit more? So we can send a query to our system. So this is a system Camel role-playing scraper for report and knowledge graph generation. So the query is, do a comprehensive study of the Turkish shooter in 2024 Paris Olympics, write a report for me, and then create a knowledge graph for the report. As we send the query, we will also set up the agent ops in order to track the agent behaviors and the whole system. After that, we start our core algorithm. Our core algorithm is called role-playing. So in this system here, we have two agents. One is the user agent. The other one is the assistant agent. So the user agent will be kind of a role-play as an a user, real user, and will send instruction to the assistant agent. The assistant agent comes back with different kinds of solutions in order to get a task done. The assistant agent here will be equipped with different kinds of tools in order to get the job done. So for example, in this case, that includes the search tool, the retrieve tool, and also the knowledge graph tool. So after specifying the task, that is to create the report and also to create the knowledge graph, We'll use the DuckDuckGo here to do the web search and the file crawl to do the web scraping. And then for the data handling part, we have unstructured I/O to do the trunking and OpenAI embeddings to embed the data. And then QJON here is utilized for data storage. And then finally, with all these tools utilized here, we got to finally go for the knowledge graph generation that we're using Neo4j here. Then in the end, we will get the output, including 3 parts. One is a report. So here's a comprehensive report for this guy. It's called use of DCAC, blah, blah, blah. And also the knowledge graph is generated here. And also you will get access to the agent ops overview for the whole system tracking and the agent behavior tracking. And lastly, Camel AI. Camel is not only a multi-agent system, as I mentioned before, it's also an open source community. Outside of it, we also do a lot of research projects. For example, Crab here, that is recently we released as a benchmark. Also, Agent AI here is a company we registered in London, and we keep hiring. So anyone interested in agents or multi-agent system, feel free to reach out to any Camel guys here. Yeah. Also, next, our product manager will do demos for our 2 initial products. Yeah. Welcome.
Yeah, hello everyone. I am a product manager in Camel team, and currently we have like 2 commercial products based on our Camel framework. The first product is the data gen, which is we use the multiple agents framework to build tools and generate synthetic data. And we have 2 use cases. The first is the role playing. We can set 2 agents and the scenario, and the 2 agents will chat to generate some unstructured natural language data. And also we have another very important tools to generate the function calling fine-tuning data. First, you will set up your SDK and also set the tools. And then we can generate and edit a C data set. And then finally, you choose the data set and generate data to be trained on. And also, we have another commercial product, which is the social media robot. We can let me show the demo. You can try the demo and upload the file, web links, and tweets. And also, we want to integrate GitHub as well. And today, because our sponsor is BentoML, so I used the BentoML dataset to build this demo, and you can access any details about BentoML. Yeah, this both are based on their website and their documents. And also, you can deploy Discord bot as well. And here are the reference. Okay, thank you for watching the demo. And we're going to hold a mini hackathon this Sunday. And anyone, if they're interested, you could reach out to us and to talk this more later. Thank you.
Great. Thank you. And for the last demo of the day, we have Savi, and he's gonna present what he has built for the last couple months. And I watched the demo yesterday, and I promise it's gonna be a very interactive one.
Thanks, Eric. Thanks for the invite. Hey, folks. So my name is Shantanu, and I'm building Savvy. Savvy is the easiest way to capture and surface your dev team's tribal knowledge. What's tribal knowledge? If you've ever been stuck on some issue and you're like, it's gonna be the first time this has happened. I wonder how we did it the last time. You're looking for tribal knowledge. Usually, you'll find it deep in a Slack thread, email, some forums, But depressingly, you'll most often find it inside someone's head, which, if it's an incident, you're going to have to wake them up. Why does that happen? Because the person who spent 3 hours figuring it out has a choice to make. Do I spend 1 more hour writing it down, capturing everything I did, or do I work on the product? Nobody gets promoted for sharing tribal knowledge. You get promoted for writing more product. But that's why I'm building Savvy, to make it super easy. So instead of an hour, it takes a few seconds, and you help your teammates. And in devs, often that teammate can be your future self. So here's the setup. Here's what I'm demoing today. I had a customer tell me that they spend hours, if not an entire day, setting up AWS machine or whatever VM they're on to run inference on custom models. I recently came across this model from Cartesia, which is designed to run on your edge. And it has 1 instruction. Everything else is left as an exercise to the reader. It's a great model, and they can't take into account what cloud provider you're going to use, what VM you're going to use, etc. So I thought it would take 30 minutes, but it took me 4 hours to find a provider that had GPUs I could use and come up with each and every flag, get it right, and I created this artifact. So if you use Savvy, someone has spent 4 hours, and you run into this issue yourself. What does it look like for the next person to benefit from your work? So let's jump into a live demo. I think that's big enough. So we're not going to make you copy-paste everything. You can search right where you work, search contextually, and you just press enter. And you're dropped right into an interactive prompt, which tells you, hey, everything else is filled out, but you need to give me the pod name. So let's say, and it automatically filled it in. I just press enter. If you notice, it also tells you, like, you're 2/5 of the way through. So we created a pod. Now we see, OK, there's 2 pods. I created 1 before. We look at our SSH keys. I'm just pressing enter. Like, all the information is right there for me. And now, moment of truth, where, so one thing I do want to call out, it takes 5 minutes for the new pod to come up. So we're going to use the one I created before in the same way, and then run it. Ignore the warnings, it's a demo. But yeah, it's going to take about 30 seconds for it to generate text on what it thinks of René Descartes. If you're curious about how I got the runbook created in the first place, there you go. So it automatically filled this prompt so the prompt was, start with René Descartes was, and then generate 50 characters. And then these are the 50 characters Cartesia's edge model generated for us. Now, if you're curious about how I got the commands and created the runbook in the first place, it's simple. After struggling and finding everything that was required to get everything working correctly, I just say Savvy record history, go to my shell history, and simply select the commands that I wanted. And that's it. Takes a few seconds. We automatically expand your aliases. We use an AI model that's custom, Llama 3.1 on Grok. And it fills out the title. It fills out descriptions for each step. You can just press E, go to your browser, and it's populated everything. You can share it, export to Markdown, store it in Notion, create user-facing docs with MDX, or you can transfer it to a team. I created one here for AGI Builders, and it's only available to people that are part of this team. So that's a quick demo of Savvy, where you can capture what you need and share with your team in seconds. If you want to check it out, go to getsavvy.so/CLI. That's it. Thank you.
Great, thank you. This is the last section of today's event, and we host monthly meetups. For the next one, it's going to be a special edition for San Francisco Tech Week. If you're going to in San Francisco around October 8th, feel free to join us again. And I'll take a picture, scan the QR code. And if you guys are more interested in Tecton, I just got this message today. They are planning a launch event, and feel free to register for it. It's an online event. It happened on September 24th. And also, if you are interested in compound AI system, and I know Chaoyu covered a lot, if you want to figure out for your LM applications, if you want to use serverless APIs, or if you want to self-host your own LMs, feel free to sign up for our live meetups, which happens on September 25th. And that's all for today's event. Thanks for joining us. We will have the office space till 8 p.m. Feel free to talk to people, grab another drink. Thank you guys for coming.